Quick introduction to a very simple forecasting method that's often used in commercial industry, which is CAGR-based forecasting. CAGR stands for compounded average growth rate, and the method can best be explained with a simple example, which is provided here. So assuming we are in year 2000 and we have a production output of 1 million units, and assuming a compounded average growth rate of 3% for the upcoming next 10 years, the expected production output in year 2010 would be 1.3 million units. The way to calculate this would be to take the last known point in history, in this case 1 million units being produced in year 2000, and then to multiply this with a factor calculated as 100% plus the compounded average growth rate to the level of 10, in this case 10 being the next upcoming 10 years. So in case we would look 20 years into the future, we would put it to the level of 20 and not to the level of 10. So this forecasting method is a very simple forecasting method and consists of two steps. The first step being to calculate the compounded average growth rate from historical data, and then to extrapolate the last known point in history, assuming that compounded average growth rate to be valid in future. And you can do that for any point in future that you would look at. But the longer you move on to the future, the more uncertain this forecasting method becomes. And I provide a very simple coding example here in R, where I read in some data from OICA. OICA is an international organization for automotive industry, and on their website they provide a series of data sets containing, for example, production output data. So in this case, I read in an XLS file in which I stored production output data for various countries and various years. I filter through that data set using dplyr, and in the end, the data frame will contain only Chinese production data for the years 2005 and up to 2018. I confirm that also by providing you with the header of the data frame. You can see the last entries from 2018, and I also show you the tail of the data frame. As you can see, the first entry in the data frame is from year 2005. Now, in accordance with the workflow, I calculate the compounded average growth rate for the years 2005 to 2018, and I then continue by predicting the Chinese production output in automotive industry for year 2030, applying basically the formula provided to you in the example here. So this is what I'm doing, this line of code, and based on that simple forecasting model, the expected production output in year 2030 for Chinese automotive industry would be provided here. This is of course a very simple forecasting method, and also to a certain extent a very naive forecasting method. It, for example, assumes unlimited growth, which certainly in automotive industry is not really valid when looking at annual production output. But for a rather limited time horizon, this might be a valid forecasting method, and it is a very often applied, it is a very frequently applied forecasting method in commercial industry. And as I said, in the description of the video, you can find a link to this very simple coding example if you should be interested.